Hi everyone. So let's discuss shifting of decimals. Now we all have seen what is a decimal. Now if we multiply decimal by tens or you divide by tens or powers of tens, how will the decimal shift is what we're going to learn. Now before that, we all know that 10 power anything power 0 is 1 or 10 we can write as 10 power 1. 100 is 10 square because 100 is what? Basically 10 into 10. All of us knows this. 1000 is 10 multiplied 3 times 10 cube. Now 1 upon 10, right? So we have seen in, or we'll be seeing in exponents rather, a power minus 1 is 1 upon a, okay? And a power negative 2 is 1 upon a square, and so on. So we'll learn more about this in exponents. So if you're dividing by 10, so the value of that is going to be 10 power negative 1. 1 upon 100 is 10 power negative 2. 1 upon 1000 is 10 power negative 3. Okay. Now, how does it affect the numbers or the decimals? Now, let's say we take 2, right? And we multiply by 10, we add 1 0. Okay, 1 0 gets added. Now, if you multiply 2 by 10 square, 2 zeros gets added. And so on. Let's say you multiply 2 by 4, 10 power 4. So how many zeros you will need to add? 4 zeros. This is straightforward. Now, if you multiply 2 by 10 power negative 1, so what are we essentially doing? 10 power negative 1 is 1 upon 10, right? So 2 upon 10 is 0.2. We'll need to introduce one decimal to the left, okay? If you are dividing by 110, okay, 10 power 1, you will introduce one decimal to the left of the integer. Now, what does that mean? Let's say if you are dividing 10, okay, 23 by 10. So what you'll do is you'll introduce one decimal, 2.3, okay? The same way you multiply 2 with 10 power negative 2. So how many decimals you will need to introduce? Two decimals, okay? 2, 0 and a decimal. So two decimals have to be introduced. Similarly, we multiply 2 with 10 power negative 3. So three decimals should be there. To the right of decimal, 3 digits, right? 2 has to be shifted 3 times. Now same, 10 power negative 4 is 1, 2, 3, 4. Okay, so this is how the values or the decimals will shift basis whether you are dividing by 10 or dividing by 10 powers or multiplying by tens or multiplying by the 10 power negative integers. Okay, we'll see these in greater detail in the next slides. Now, so we'll look after multiplication for now. If you multiply by 10, okay, the decimal will shift one place to the right. Okay, that means what are we saying? 2.36 into 10. Okay, the decimal place will shift 1 to the right, will become 23.6. Okay, now let's say 365 into 10 square. 10 square, so two digits to the right, 1 2, so 236.5. So this is how it will affect the decimal shift will happen. So we have seen some examples. Let's say 29.563 into 10 square. So 10 square means two digits to the right, 1 and 2. So 2956.3. Similarly, you multiply by 10 power 4. How many decimals? 4 decimals, right? 1, 2, 3, and 4, right? 3.96. So simple and straightforward when you're multiplying by 10 powers. Now we have also seen when you multiply by 10 power negatives, you shift that many decimals to the left. For example, we have already seen, okay, 2.3 into 10 power negative 1. So this decimal shifts one place to the left. So this becomes 0.23. Okay. Now this into 10 power negative 2. Negative 2 to the left, 2 places to the left, 1 and 2. Okay, we all know if there is no decimal, you add 0, right? Basically, a 0 will be introduced. So if you see example 10 power negative 1, this decimal will come to one place, right, to the left. So 2.9563. The second one, 10 power negative 4, so 4 places to the left. So we have only one place, then we'll need to introduce for the remaining 3 places 3 zeros. Okay, hope this is clear. 1, 2, 3 and 4. So multiplying by 10 power positive numbers, multiplying by 10 power negative numbers, negative integers. Okay. So this is about multiplication and how the decimals will shift. Now we'll come to the division. Okay. So important point is dividing a number by 10 is equivalent to multiplying the same number by 10 power negative 1. What does that mean? We have seen that you either for a 23 you divide by 10, you get 2.3, or you multiply by 10 power negative 1, you get same, one place to the left. Why? Because 1 upon 10 is same as 10 power negative 1. So the operations of dividing something by 10 powers is same as multiplying that with the same 10 powers, right? 10 power negatives. So this becomes easy once you understand, right? When you're dividing by 10 power 2, what happens? You have to take 2 places to the left. If you multiply, okay, if this is multiplication, 2 places to the right. If you divide, 2 places to the left. So it acts the opposite way in division, basically, to that of multiplication. Now 2 places, this will go here and this will go here. So that's what a 0 is introduced. Now 3 places, right? 1 place, 2 places are not there, so you'll introduce 2 zeros. Okay, so straightforward, division or dividing a number is same as multiplying the number by its reciprocal, basically. Okay, we'll get more clarity also in this. Now 32400. So if I have to introduce one decimal over here, what I'll do, I'll multiply by 10 power of that decimal. Okay, because 3240.0 is nothing but 3240. Okay, because 0 will not have any value after the decimal. Or if I want to introduce decimal in 2 places to the given original number, let's say this is the original number, right? So what are we doing? We are introducing decimals to that number and compensating it by the 10 powers. Now if I want to introduce decimal after 2 places to the left, so I'll need to compensate by 10 power 2. Okay, because 10 power 2 will introduce 2 decimals to the right, or will add 2 zeros, right? Same as you can see, if you want to introduce decimal in 3, you want to take decimal 3 places to the left. 32.400 into 10 power 3, and so on and so forth. Now you can see decimal places is introduced 5 places to the left. Okay, so 10 power 5 and so on. So that's what is written here. As decimal in the first number move 1 place to the left, the power of 10 will increase by 1 to compensate. Okay, I hope this concept of shifting the decimal is clear. Now we'll see a bit of decimal operations. How do we add or subtract the decimals, right? Okay, the main or the most important thing is the number of decimals should match while adding or subtracting the decimals. Now what do you mean by match? I mean, when we try to add, there are 3 decimals here and there is 1 decimal here. It's not matching. So how do we match? So what we mean by that is you write both the decimals in the same column, okay, in the same vertical line, and the second number have 1 decimal, right, or 1 digit to the right of decimal. So This is how you will need to add. You will need to match the decimals. And of course, if there is no number, what we'll do, we'll add 0, nothing else. Now we add it normally, right? 7 plus 0, 3 plus 0, 8 plus 3, 11, 1 carries. So 3 plus 5, 8, nothing, there's no carryover. So 178.137. It's as simple as that. That's what, whenever you're adding or subtracting, you just match the decimals, right? Now, there is no decimal here. How do we match? We know that 53 can be written as 53 point any number of zeros. As we have discussed, there is no value to 0 to the right of the decimal, okay? But while adding or subtracting, this comes very handy. Now, the second decimal is 8267.6. Now we have to subtract. How will we do? The same way. Okay, carry a 1 from here. 2 will remain, so 1 comes here. So what we have is 10 minus 7, 3. So there's a 10 there. Sorry, there's a 9 there, right? 1 is carried, so on. So all of this will be 9s. So we have, okay, we'll just write. And this is 10. So we have 3, and we have 7, and we have 1, and 2, right? So 2 minus 6, we'll need to borrow 1, 2 from here. That becomes 12. 12 minus 6 is 6, and we have 4. Okay, so I hope this is correct. 46.1733. Again, what we have done is just matching the decimal. Okay, you all can try this. Pause and try. So I'll be quickly solving this. Okay, match the decimals. 3, 3, good to go. 14, 10 plus 2, 12, 10, 1 carries, so 5. 5.024 should be your answer. Same way, 4.982, oh sorry, and a decimal, 9, 2, so 2 zeros, I'll have to subtract. So straightforward, 2, 8, and 0, and 2. These should be your answers. So that's how you'll need to add or subtract the decimals. Now, how do we multiply? We'll see multiplication and division. Bit tricky, but if you understand logic, it's straightforward. The first step, what you'll need to do is count all the digits to the right of the decimal. When I say all the digits in all the numbers. So there are 2 digits here, there is 1 digit to the right of decimal. So total we have 3 digits. Okay, step 1, you have counted. Step 2, remove all the digits. Okay. I removed 2 digits from first number and the 1 digit from second number. I will multiply the normal way. 24 eighths is 192. Then in the second step, you introduce that many decimals to the left of the answer. Okay, 192, you introduce 3 decimals to the left, you get 0.192. It's as simple as that. The only thing is you need to count the decimals, multiply it normally, and add that many decimals to the final answer to the left. Okay. So there are 3 decimals here and there are no decimals. So total we have 3 decimals. So what we'll do, we'll take integers, 2 multiplied by 3100. Okay. So this will be 6200. Remember, these are not decimals, so we are not going to change anything. We are only going to let go of the decimals. Okay. Now, to this, how many decimals we'll need to introduce? 3. So 1, 2, 3. So your answer is going to be 6.2. It's that simple. So we'll try one more. How many decimals? Count the number of decimals. 1, 2, 3, 4. Okay, 4 digits are there. 4 multiplied by 6, 1, 2, 3, 4. So 24, 1, 2, 3, 4. So you put decimal 4 places to the left, which is the answer is going to be 24. It's as simple as that. We have seen decimal operations of addition, subtraction, and multiplication. We'll see the division. What you need to do is, first step is make sure that the denominator is a whole number. Okay, we don't want decimals in the denominator. Now, how do we do that? Here it doesn't matter. Let's say you have something like 1.5. So you'll need to let go of the decimal. So there is one decimal. So you'll multiply and divide by 10 to numerator and denominator. That will give us 15.7 upon 15. Okay, this is going to be your step number 1. So that it becomes easy for us to basically divide. Okay, now you will do the same thing. You will count the number of digits to the right of the decimal on the numerator, because denominator doesn't have any decimals right now. So there are 2 decimals, 2 digits to the right of decimal. Then the same way what we have done for multiplication, you divide normally. Okay, so 3 4s 12, negative 1 4, so 3 4s 12. Subtract 2 4, we have 8 here, so we get 448, and you will introduce 2 digits to the left, so it becomes 4.48. That's going to be our final answer. So hope this is clear. Now let's try this. So step 1 is we let go of decimals in the denominator. So one place or the one digit, so multiply by 10, you get 193.6 upon 11. Step 2, count the number of digits. There's only one digit. Okay, now we divide it normally. So if you divide 11 once, 83 is there, 11 7, 77, then we have 6 here, 66, so 11 6, 66, completely divisible. So step number 2, we get the answer as 176. To this you introduce one decimal to the left, so that is going to be our answer. Okay, one last, you can try and solve, a bit tricky. Step 1 is checked, there's no decimal in the denominator, good to go. Step 2, count the number of digits to the right of decimal. There are 6 digits. We'll need to introduce 6 decimal places later. First we'll divide this, let go of everything. What remains is 2304. You divide by 12, you should get 192. You can do the division, or let's just do it fast. So we have 11, 12 8s, 12 9s, 108. 2 remains, and 4, 12 2s, right? Now you will need to introduce 6 digits. We have only 3 digits, so the remaining 3 will be compensated by zeros. This is going to be our answer. Okay, hope the concept is clear. We'll solve few more questions, 2 3 more. Okay, first we'll need to simplify 4 multiplied by 10 power negative 2. So we have seen, if you're multiplying by 10 power negatives, you introduce that many decimals to the left. So 1 becomes 0.4, 2 becomes 0.04. Same for the second one decimal is there, remaining 2 will be compensated by 2 zeros. Now this becomes easy. We just need to match the decimals and subtract. So we'll borrow 1, this becomes 10, and this becomes 3. 10 minus 6, 4, and 3 is remaining, 0 stays the same. The answer is going to be 0.034. What is the thousandth digit in the decimal equivalent of 53 upon 5000? Okay, now how do we write 5000? 5000 I can write as 10 power 3, right? 5 into 10 power 3. Now, one way is 53 upon 5. We have seen 1 upon 10 power 3 is nothing but 10 power negative 3 in the first slide, right? So I'm going to let it be for now. What I'll do is I'll solve 53 upon 5 with the normal long division. 5 tenths, 50. 3 remains, so less than that, so I put a 0. 6 times. The answer is going to be 10.6 divided by 10 cube or multiplied by 10 power negative 3. Both are same. So how many digits or decimals we have to introduce? 3, right? We have 2. Remaining 1 will be compensated by a 0. In this, they're asking the thousandth digit. We have seen digit places before. This is 10th. First digit to the right of decimal. This is 100th. And 0 is 1000th. Okay, I hope the concepts are clear of digit places. Okay, there's a shortcut. I'm not sure if I'll need to introduce, but I like this shortcut. Whenever there is 5 in the decimal or in the denominator, what I do is I try to make it 10. It becomes easy for me. How do I make it 10? I multiply by 2. What happens? So I can directly put that many number of decimals. It becomes easy. So if I want to apply this, what I'll do is I know that 5 into 2 will become 10, or 5000 into 2 will become 10,000, which is 10 power 4. Now it becomes quite easy. I just need to add 4 decimals, right? So 3 are there, remaining 1 will be compensated by a 0. So you can avoid that. So it's up to you. Okay, one last question. If k is an integer and this into 10 power k is at least means greater than or equal to 1000. I want at least 2 pence. That means I want minimum 2 pence, right? 2 or more is fine. Now, find the least value of k. So the best way I can see the options, always look at options 5, 6, 7, 8, 9. So I can plug in and check. If I put k is, k is 5. So let's see what this number will become. 360 multiplied by 10 power 5. So if I multiply by 10 power 5, the decimal goes 5 places to the right. Okay. So count 1, 2, 3, 4, 5. So 2073.6. Great. So if it is 10 power 6, so I have to shift to 6 places, right? 1, 2, 3, 4, 5, 6. So as you can see, this is already greater than 1000. This is also greater than 1000. All of these are going to be greater than 1000. So the least value, important is what is the least value of k such that this is greater than 1000. So the answer is going to be definitely 5. Okay, a lot of concepts in this topic, shifting of decimal, right? This multiplication, division, and how we add or subtract decimals or multiply and divide. Make sure you write all of this, and I'll see you in the next video. Thank you.